I recently serendipitously had two meetings where someone brought up to me the power of 10 rules from NASA in programming. One happened today and one happened yesterday. Yesterday, the programmer was a programmer who had worked on very heavy equipment that was used in critical industrial operations. And that made sense to me. I could see where these relatively extreme rules and limitations would be necessary so that static analysis and safety was of the utmost concern, much higher concern than maybe any other consideration, including the developer's ease of building the code base. These rules probably help in that situation make sure that the operations are always online. However, today I interviewed with someone who was familiar with these rules and versant in them from the standpoint of business programming or programming in kind of like a normal setting, maybe working in a bank or a financial company. And from my standpoint, I thought, why would you go through and apply to yourself a set of restrictions or handcuffs that prevent you from building software as effectively and efficiently as it's possible to do in modern programming languages with the idea of ultimate safety in mind when you're not in a critical situation? For example, I've worked in investment banks, and it's very important that their trading capability stays online. However, that does not mean that every trading system always has to be online. It's possible for like a reporting system, maybe it has redundancy, to have one system go offline and another one take its place. Or it's possible if it's a trader's desk or a trader's UI, to have it be reset or restarted. Maybe the trader's at lunch, something like that. There's definitely cases where these things don't have to operate with ultimate safety, and you can work with a more practical mindset. And I wonder sometimes if taking such an ultimate approach to coding doesn't restrict you, slow you down, and actually prevent you from creating the best code in a short amount of time. Now, this first rule, restrict all code to simple flow control structs, I actually agree with. I've never really been in a situation, honestly, in 30 years of programming where I have encountered the use of the goto statement. I do love the Donald Knuth argument or article, Structured Programming with Gotos, and I think he makes a great point, and I think it's actually one that's aligned with this rule number one of how to use goto safely and where it should be used. I have actually used goto in a situation where we were developing a DSL, like a language interpreter. And so that might be a situation. There's certain specific situations where goto is actually useful or required. So language interpretation or development might be one of those places, but pretty much every other place in software, and especially in business software, it's not useful. It's not used. Frequently you can use break instead of goto. So I definitely am more aligned with this one. However, this rule number 2, I find it really interesting. Says, give all loops a fixed upper bound. This is so a static analyzer can always prove that the loop is ending, that it's going to terminate. And I think that this is so problematic. I wonder how often giving a loop a fixed upper bound caused a bug versus the number of times when it prevented a bug. And I almost think maybe instead of give all loops a fixed upper bound, maybe it should be check the exit conditions of all loops. Make sure that all loops have an exit condition. I actually think even in that case, I don't necessarily totally agree with it, because I have been in the situation where I've used, this forever structure that's available in different languages. I write a lot of services. I write a lot of web services. And these web services, usually all they do is loop on some sort of an event stream. And maybe the daemon process would loop forever. So I don't necessarily agree with this. I wonder about injecting some sort of limit that, seemed fine at the time, but later on when things grew and then there was more items in the loop that was expected, it exited prematurely. And how hard would it be to find that bug of, there's 1,001 members in the iterable set and your loop is fixed at 1,000 and the one member didn't get included. When would you find it? How would you find it? How would you debug it? It seems like a terrible rule that introduces a lot of scary complexity. I don't even know if this is safe in a safe scenario. Do not use dynamic memory allocation. This is really I think this is really about C and the C language. In a language like Rust, in many other languages, Go and Java, garbage collected languages, we have reference counting. So we don't have to worry about this anymore. Memory cannot be leaked in the way that it was back in the C days in these modern languages. So I really think not being able to dynamically allocate memory is really only should be done in very specific instances. If you are in some embedded setting, some ultra safe situation, you're programming, a big truck, then maybe, I agree, dynamic memory allocation might make the static analysis too difficult. But for all the rest of us who are using general purpose computers to do business, I strongly recommend you don't follow rule number 3. No function should be longer than what can be printed on a single piece of paper. 60 lines of code. This is interesting. I definitely agree with keeping functions small and having a single purpose that makes sense, but this is just pedantic. We don't know. I've encountered these things because I use linters in my coding, and so frequently the linter will be set at some level, some threshold, 10 lines, 20 lines, 30 lines, 61 lines, and then you have a function. Imagine you have a function that's a dispatch statement in some service, and it's calling all these different paths that could go out. Like maybe it's a user interface, and these are the events in the UI, and these are the handlers. You might have that function might be 61 lines, and then it doesn't make sense to break it up at some arbitrary point or to break it into 2, because now you have 2 function call overheads in order to dispatch all of your methods. So sometimes it doesn't make sense. I mean, of course, you could reorganize this into some sort of a map or jump table. But even that, is that as clean as just using a dispatch control flow of a function? I think arbitrary rules like this aren't always necessarily helpful, and restricting the code like this is probably just going to leave a lot of gnashing of teeth of how to do things and force you into doing things maybe the non-ideal way, less elegant way at times when you don't want to be forced. The code's assertion density should average to 2 assertions per function. This is nice. I do like this. I do think that, on the inputs of a function, you should generally check and do bounds checking, various input and output checking, and sanity checking. I don't know where they come up with the number 2, is order the number of parameters a better number? 2 seems like just random. I might say greater than 1 and order the number of parameters. I don't know how they come up with the magic number 2. They say that they're looking at statistics over industrial coding efforts. God help us if we're writing industrial code. Declare all data objects in the smallest level of scope. This is another one that I agree with. We should always minimally scope data. Everything should be a black box. Everything should be hidden to the greatest extent possible. So this makes sense even in business programming. Each calling function must check the return of non-void functions. This is funny. This is something I always used to do in C. But most programmers don't do this. Most programmers don't even know that you can use void to indicate that you wish to ignore the return value of some function. This is definitely something you should do. You should check the return values. Return values have meaning, and ignoring the return value frequently leads to bugs, especially if it's an error return value and you're just assuming success and proceeding. That's something more programmers need to do. Eliminate the use of the preprocessor. That's fine. That's the only. Most people probably don't care about that nowadays because we don't have a preprocessor. I definitely agree we should not be handling fancy macros and writing a bunch of fancy macros instead of code. Nowadays, with generics in high-level languages, good high-level languages, they have generics, and so we don't need to use the preprocessor to do those kinds of things. It can all be handled in generics. And then use of pointers should be restricted. No more than one level of dereference. Yeah, so treat it like an array, not some deep, object. I think this is generally a good idea. I definitely have encountered situations where one level of recursion was not enough, right? Maybe you have a nested array or things like that. But I understand what they're trying to say, and, it seems reasonable to try to limit it. I don't agree with putting a maximum restriction on it, but let's not go over the top with dereferencing different pointers and down nesting down into different scopes. Pointers are easily misused. I mean, one might say to use smart pointers, which are much less easily misused. And you might also argue that you should use a programming language such as Rust that will help avoid miscounting or accessing things that have gone out of scope, things like that. All code must be compiled. This is a good one again. Enable the compile warnings at the most pedantic setting. That's one I agree with and I love cleaning up the warnings. I've seen a lot of Java projects, JavaScript projects where they just had hundreds of linter warnings. And usually those things are, really easy to clean up. Usually it's tiny pedantic things like the spacing of things. But people just persist in having tons of warnings. So I do agree with that. So overall, about half of it, following the rules, half of them make sense. But sometimes it doesn't make sense. And I would say for your business software, understand the rules, know what safety is, but be practical. Don't create restrictions that prevent people from writing the code they need to write.